Hello everyone, welcome back once again. So, as we discussed at the end of the previous video, we have successfully finished the first two steps of our workflow. We loaded the source file and split them into smaller chunks, and those chunks are what we will now pass into the embedding model. In this tutorial, we'll focus on the next two steps in the pipeline, creating the embedding and saving them into the vector store, also known as knowledge base. To generate the embedding, we will be using OpenAI services. There are many models available. The right choice always depends on your use case. There's a platform called Hugging Face that lists a wide range of models along with the details, such as their supported use case, performance metrics, and community reviews. Based on that information, you can decide which model best fits your needs. Since our work is primarily text-based, OpenAI is a great choice because it performs exceptionally well in the text understanding and text generation. Now, once the embeddings are created, they need to be stored somewhere. That's where a vector store comes in play. You can think of a vector store as a database designed specially to store embedding. Here as well, we have several choices. We have FAISS, we have Pinecone, Chroma, and many more. All of them serve the same fundamental purpose, though each comes with its own advantages and disadvantages depending on the use case. For our scenario, we'll be using FAISS because it fits our requirements well. Also, you may hear the terms vector store, vector database, or knowledge base used interchangeably. Although the terminology differs, they all refer to the same core idea. We generate embedding, we need a place to store them, and that storage is handled by a database. That database is what we call a vector store. Nothing more than that. So, now let's move into the code and walk through these next two steps. Here, before starting the code, what we'll do, we'll go to the imports and you can see here a warning coming. This warning is coming because I've upgraded my LangChain version. So I'll go ahead and correct it by importing it in a correct way. That is LangChain _ text splitters. That's the correct way to import it. Now we'll go ahead and write our code. First, I'll comment this section out since we no longer need it. Now, what are the two tasks we are focusing on? We'll be generating embeddings and we'll be creating a vector store. These are the two things we'll be addressing in this module. Alright. The first thing we need to do is generate embeddings. As mentioned earlier, we'll be using OpenAI services for this. This means we need to provide OpenAI API key, which we have created in the previous section. I hope you have already generated your key. If so, you can paste it here. I'll provide a variable called OpenAI _ API _ key, and this will be assigned to the API key value. Keep this in mind, this is my personal API key. I'll remove it later so it won't work for you. You will need to visit OpenAI website and generate your own key by following the steps we have discussed earlier. Okay, now that everything is set up to generate embedding and API key is in place, we can start calling the OpenAI services. To do that, we'll be using LangChain. We have already imported the LangChain package. At this time, from LangChain embedding, we'll import OpenAI embeddings. As I've mentioned multiple times, we'll rely on OpenAI for embedding generation. So, this is the service we need. With this imported, the process becomes very fast forward. All we need to do is initialize Open Embedding. Of course, it requires our credentials. So, we'll use OpenAI _ API _ key. This value is stored in a variable, so I'll simply reference it here. Once this is done, it will generate the embeddings for us. We'll store the result in an embedding variable. Next comes the vector store. Let's take care of that as well. I'll explain everything again in a clearer way. As discussed earlier, we are going to use FAISS as our vector store. FAISS is a library developed by Facebook and it stands for Facebook AI Similarity Search. It is highly effective, which is why we are using it here. To use it, we once again rely on LangChain. From LangChain _ community dot vector stores. We'll import FAISS. LangChain supports many different vector stores, but for our case, FAISS is the one we'll use. Now, we'll call FAISS dot from text. This method takes two parameters. If you think about what we are doing conceptually, we are creating a database. A database usually stores pair of values, keys and values. Here the keys are our text chunks and the values their corresponding embeddings. Of course, the actual implementation is more complex, but this simplified explanation helps understand the idea. So, what does database need? First, it needs the chunks of text. Those chunks are stored in the chunks variable, so we pass that in. Second, it needs the embedding. Those embeddings were generated by OpenAI and stored in embeddings variable. So we'll pass that as well. And that's it. We'll assign the result to a variable called vector underscore store. So now let's review what just happened. This line of code is responsible for generating the embeddings, and this line is responsible for creating the vector store. Although it looks like a single operation, there are actually three things happening behind the scenes. First, embeddings are being generated using OpenAI. Second, a vector database, FAISS in this case, is being initialized. Third, both the text chunk and their embeddings are being stored inside the database. So, even though it appears as just one line of code, a lot of happening internally. Now, think about this for a moment. We only wrote 2 lines of code. If you recall our earlier discussions on embedding, we talked about how powerful they are, how they are created by neural network trained on massive data sets over many years. And here we are able to leverage all of that power in just 2 lines of code. Just 2 lines. That is the future of programming. We'll be increasing relying on ready-made LLMs like OpenAI models and Llama. Based on our use case, we'll feed our data into these models. We'll tune the accuracy by adjusting the parameters. We'll explore that later. But essentially, everything gets done in just few steps. Our vector is created, our embeddings are generated. If you look back at the overall architecture, you might have expected a lot more complexity at the start of this video, but with only 2 lines of code, we have accomplished all of it. We have created embeddings. We have built a vector store and stored the data in it. I won't display the stored data because it would extremely complex and difficult to interpret, and it would likely cause confusion. But behind the scene, vector store is ready, the embeddings are stored, and everything is set up for future operations. Once again, this highlights where programming is headed. We will use pre-built models, fine-tune them with our own data, adjust parameters, and quickly arrive to production-ready solutions. Alright, so we have completed these 2 steps. Our source data has been converted into embeddings. Those embeddings are stored in a vector store. Everything is now ready to be used. Next, we need to focus on the second part of this system, the user interaction. We need to build a way where user asks questions, retrieve relevant information, generate a response, and display it as output. We'll handle all of that in the next video. I'll see you there. Thank you.